Hi, in this video we are going to have a look at some different types of solder to see how they compare when soldering through hole parts. And as you can see, we've got quite a big array of different types, so completely spanning the price range as well as the alloy composition. So on the left we've got the lead-free alloys in green, then we've got all of the lead-based alloys on the right hand side, and the lead-free ones we've got the basic tin copper alloys, and then we've also got some with silver in there. Then we've got our 60-40 lead-based solders in the middle here. Then we've got some with silver included in the alloy here. And then we've got the 63-37 lead-based solders. So slightly different composition to the 60-40. Still tin and lead, but the 63-37 ratio creates a eutectic alloy, which means that when you're allowing the solder joint to cool, there's a very sharp transition between it being a liquid and a solid, and that means that you're very unlikely to get dry solder joints from your component moving while the solder is solidifying. So as well as different alloys, we've got quite an array of price ranges as well. So we've got some cheapy Chinese rolls of solder here. We've got some Taiwanese solder, the pros kit stuff. This has got some silver in it, so it might be quite nice. And then we've got the more expensive stuff such as the Kester, obviously the multi-core, which I've got quite a lot of, and the Weller's a reasonably expensive priced solder as well. So I don't think I'm going to test all of these. I think I'm just going to test the ones that are going to be most interesting or most relevant to the people watching. So to start with, we'll have a look at some of the low cost ones because these will be the most attractive to hobbyists. We'll have a look at some of the more popular brands such as Kester and multi-core, but what we'll also do is make sure that we've got an array of different alloys in that selection. So for example, this Felder Solder we've got in both just 60-40 lead and also with the silver in, so we can see how the difference is between those two. And we'll also try and incorporate a range of different fluxes in the solder wire as well. So to do the comparison, I've had these two PCBs made up by JLC PCB, and in this board we're going to solder some 20-way pin headers to each row of holes on the board, and each row will be for one different type of solder. And this will just be to simulate general purpose soldering, just to see how it behaves, how the solder melts, how it flows, and also, once it's solidified, the overall look of the solder joint. And then we've also got this board here where we're going to put a measured amount of unmelted solder in the center of each pad and heat up the board and see how the solder flows, and that will give an indication of how good the flux is. If the flux is quite active, what will happen is the solder will want to flow over the whole of the pad, and if there's not much flux in the solder wire, or if it's not very good, or if the alloy is not very good, it will probably just blob in the middle and just sort of melt, but not reach the edges of the pad. So this is the array of solders that we are going to test in this particular video. On the right here we've got the lead-free alloys, so one without any silver in and one with 3.5% silver. And then we've got some from Amazon, which is just tin and copper, so 99% tin. Then we've got some cheap Chinese ones to see how they behave, and these were only something like £2 a reel for 100 grams, so really quite low cost. And we've got some pros kit solder here with 2% silver in. Then we've got some Kester solder. This is 63-37 Eutectic Alloy. These are also Eutectic alloys as well, so these should all behave quite similarly if the flux is good. Then we've got some Felder branded solder. These are both lead based, but this one has silver in it, 2%, and this one doesn't. Then we've got some old school Maplin solder, and this is what I learnt to solder with, and in my opinion sort of really flows well. It's got that really old school smell to it. It's just plain 60-40 with flux class 5A solder in it, so it's got a really old school smell to it, but you can't buy it anymore. But I thought it'd be an interesting comparison because in my opinion this is one of the best flowing solders that I ever used. Then we've got some Duratool solder. This is relatively low cost. You can buy it from Farnell and CPC and eBay. Then we've got this Auto solder from Wharton Metals, and it's got a really interesting alloy. I think it was sold as sort of trying to save your or get more life out of your soldering iron tip. So it's got a 50% silver, 1.4% copper and 48.6% lead, so a really odd composition. I've not come across another type of solder with this kind of composition. And then we've got some multi-core solders here, so a 6040 solder with Ursin 309 flux, and then we've got 3 solders here with the same alloy, so 62% tin, 36% lead and 2% silver, but there's 3 different types of flux in these. So we've got Ursin 362, Crystal 505, and then their proprietary smart flux. So let's have a look at how these behave. Right, so starting off with the Maplin solder, this did flow very, very nicely and gave really nice shiny joints. It does appear to have quite a lot of rosin-based flux in it, so it tended to spit quite a lot, but other than that, a very nice solder to solder with. Next up is the multi-core branded 6040 solder, and this also has a rosin-based flux, and I think it's got a similar amount of flux in it, but it didn't tend to spit anywhere near as badly. But as you can see, there's quite a lot of residue left behind, which will need cleaning up after the solder job. But again, this gave very nice shiny solder joints. Here we have the multi-core smart solder, which has the addition of silver in it and their proprietary smart flux. And this was a very nice solder to solder with. It gave extremely shiny joints in comparison to the other two and did flow really, really well. No spitting at all, and it did seem to have a little bit less flux in there. There's less residues overall. Here we've got the multi-core solder with silver in it, and this is with the Ursin 505 flux. And this was a very nice solder to solder with as well. It flowed extremely well. Very, very shiny solder joints. And it does seem to have a little bit more flux in there. You can see quite a few more residues left over and a little bit of spitting on this one. You can see around the solder joints there's quite a few blobs of flux that have been spat out from the joint. This is the multi-core silver solder with the Ursin 362 flux, and you can see this is quite a rosinous flux, a lot of it in there, so there's tons and tons of residue on this flux despite I think it only having 3% flux. But again, a very nice solder to solder with, but quite a lot of spitting, way more than any of the others that we've tested so far. Here we've got the Wharton Metals Autosol solder, and surprisingly this flowed really nicely, and it appears to have very little rosin in there. The residues are almost completely clear, but again it flowed very nicely and no problems. It's not quite as shiny as the others from what I could see at this point, but certainly no problems with the soldering at all. This is the mechanic solder which I bought from Banggood, and this is a slightly thinner solder wire, so I've had to feed in quite a lot into the joint, so this was a little bit more tricky to solder with for through-hole parts, but it flowed very nicely indeed. Certainly no problems with this one. In fact, if I hadn't have known it was a Chinese solder, I wouldn't have known any different from any of the others. This is the Jinhoo branded solder, which is another Chinese one, but it was actually a little bit more expensive than the mechanic solder. And this seems to have quite a different visual appearance once the solder has solidified. You can see it's quite grainy. It didn't seem to flow too badly, but the appearance is quite different. There's certainly something slightly odd about this particular solder wire. Next up is the Duratool 6040 solder with 2% high activity flux. And this is quite a bit thicker than the others, so I'd got used to feeding loads of solder, and you can see I made a little mistake here. But this flowed really nicely, very shiny solder joints, and certainly no problems whatsoever with this solder. It's very nice to work with. Here we've got the Pros Kit 2% silver solder, and this is even thicker actually, but very nice solder to deal with. It seemed to flow way better than any of the others, hardly needed any heat to get it into the joint, and it seemed to have quite a lot of flux in there, so it also flowed very nicely and gave shiny joints at the end. Next up is the Felder branded solder. This is a German solder and very nice indeed. It has quite a lot of flux in it and quite a lot of rosin content. You can see it's deep yellow colour. So this might be a little bit difficult to clean off afterwards. I've noticed the ones with a high rosin content do tend to form quite solid residues on the solder joint, but certainly no problems flowing this solder at all. Then we've got the Felder Solder with the addition of silver into the alloy, and you can see this flows even better and is super shiny at the end of it. Again, quite a lot of rosin in the flux, so you can see that deep yellow colour, but again this flowed very nicely indeed. So next up we've got the Kester solder, and this is the Eutectic Alloy, so you should see a very sharp transition between it melting and then solidifying, but certainly no problems with this at all. It seems to have quite a lot less flux than all the others based on the amount of residue left on the board afterwards, but certainly a very nice solder to deal with. Right, so next up we've got the lead-free alloys, and this is the 99% tin alloy, and this flowed really nicely indeed. The only thing that I noticed was this has a lot of flux in it and it spits really badly. You can see there's spitting all over the board, and it's quite easy to get a ton on your fingers and your hand, but certainly no problem at all with this solder in terms of its solderability. Next up we've got the multi-core lead-free solder with the addition of silver, and you can see this looks very slightly more shiny and seemed to flow a little bit better, but still loads of flux in this and it was spitting all over the place. So not quite as pleasant to work with as some of the lead-based alloys, just from that perspective. And then finally we've got the Amtex solder from Amazon, and if I hadn't have known, I wouldn't have known that this was a lead-free alloy. It seemed to flow very nicely indeed, but it is a very thick solder wire, as you can see, so not all that great for PCB work. Right, so now I've cleaned up the PCB, you can see there's quite a difference in appearance between all of the different types of solder. So while I was soldering, I was thinking they were all flowing really well and that there wouldn't really be much difference, but let's have a closer look on the microscope. Right, so first up we've got the Maplin Solder, and this is a 60-40 mix with a rosin flux, and as you can see the appearance is quite good, relatively shiny and good coverage over the pad. Then we've got the multi-core branded 60-40, which is also a rosin-based flux, and as you can see also the appearance is pretty similar to the Maplin solder. Then we've got multi-core branded with the Smart Flux, and this is with the addition of silver to the alloy, and this looks very, very shiny indeed. And so does the one underneath, which is the multi-core with the Crystal 505 flux. The multi-core with the Crystal 362 flux is really, really shiny in comparison, and it had really good coverage and flowed really well while I was soldering this one, so this one looks really nice. And then we've got the Wharton Metals Auto Solder, which is the interesting alloy that I've not come across, and as you can see it's got a really strange appearance. It did flow quite well, but yeah, the appearance is quite odd. Then we've got the Chinese branded Mechanic Solder, which is the Eutectic Alloy 6337, and this flowed really well under the soldering iron, so I was quite impressed with this, and the appearance is quite good as well on this one. This is the Jinhoo branded solder from China, and although it flowed really well, it's got this very strange appearance. It's the same alloy as the Mechanic above, but it's certainly dried quite strangely, or solidified quite strangely. It's got this slightly weird grainy structure to it. It all looks absolutely fine in terms of the overall appearance and the structural integrity, but it has got a strange appearance to it. This is the Duratool branded solder, and this is just a plain 60-40 mix, relatively low cost solder, and as you can see this has given quite good appearance. Next up is the Pros Kit solder, and this is extremely shiny, and again this one has the addition of silver in there, so definitely the silver seems to give it a very shiny appearance, and it also flowed extremely well. Here we've got the German branded Felder Solder. This is the 60-40 mix again with the rosin solder, and pretty similar appearance, not quite as shiny as the ones with the addition of silver, and the one underneath it is Felder branded with silver in, and you can see quite clearly there is a difference in appearance, but actually this isn't quite as good as some of the other silver alloys that we've used. Next up we've got the Kester branded solder, and this also has quite a shiny appearance, not too far off one of the ones with silver in actually, but this has no silver in it at all, but very nice solder. It flowed really well as well. And then we're on to the lead-free alloys. So this is the 99% tin solder, and actually this is very nice. It was spitting quite a lot during soldering, so the flux was particularly active and it seemed to have quite a lot in there, but the overall appearance is quite nice, and I certainly had no trouble using this one. And then this is the multi-core branded with the addition of 3.5% silver into the alloy, and interestingly the appearance isn't quite as good actually. And then finally we've got the Amazon branded solder. This is a lead-free alloy, but it's extremely shiny, way more so than either of the other two lead-free alloys. But yeah, this one also flowed very well, and you can see the reflection of the pointer in here. It's very, very shiny indeed. So some pretty good solder across the board really. Just the Jinhoo branded solder really was quite different in appearance, and also the Auto Sol solder with the strange alloy, but the rest of them seem to flow really well, and really nice appearance on all of the solder joints that I have done on this board. Right, so next we're going to test to see how the solder spreads on its own without any additional agitation. So I've got this board here with the immersion gold finish. Each square is 20 by 20 millimeters, and we've got 30 cubic millimeters of solder on each pad. So we've got all of our different types of solder lined up with the lead-free ones at the end here. And we're going to heat up the hot plate as far as it will go, but I suspect it won't melt the solder on its own. Some of these have fairly high melting points, specifically the lead-free alloys. So we'll also use the hot air station at a very low airflow rate so as not to blow the solder around, just to assist with melting the solder. And we'll continue doing that until there's no further spread on its own. So we'll try and give each pad an even heating with the hot air gun, just to see how they flow on their own. So what this should show is how good the flux is in each of the solders, and also how much flux is in each one. So typically, if there's quite a lot of flux and it's quite active, what will happen is the flux will spread out, clear the area of oxides, and then the alloy will be free to flow over the entire pad. What I don't know is whether this will also show whether the alloy is any good in the first place. So if we've got some impurities, it may not flow as well as a carefully formulated alloy of the pure materials. So we'll be testing quite a few things here. I may not be able to draw any specific conclusions, but we'll see how it works. Right, so the first thing to note from that test is this Jinhoo solder, I really had trouble melting it. So I'm slightly suspicious firstly of the alloy. I don't think it really is that, because we do have this weird grainy structure to it. So either it's not this, or the alloy also has some other impurities in it. Also, it's only got 1.2% flux, so that probably explains a little bit why it's having a little bit of trouble flowing over the pad. But interestingly, I didn't notice any trouble with soldering with it with the soldering iron, other than the weird appearance to it. The other Chinese solder, the mechanic solder, seems absolutely fine. So we've got a really nice shiny solder here, and sort of fairly uniform spread compared to some of the others. Maplin solder, the 6040 with a rosin flux, had no trouble here. And then we've got 4 multi-core solders, and I was potentially expecting this one to flow a little bit further. It's got what they're naming the smart flux, which is quite a high activity flux, so I was expecting this to spread quite rapidly over the pad, which it didn't do. It was actually the Ursin 362 flux that had a little bit more spread than the others, so that's quite interesting there. One thing to note is this is the Pros Kit solder, 2% silver, and this exhibited the highest spread out of all of them. And interestingly, I did actually do this test twice, and we got the same amount of spread on the other board, so that is a true result. So for whatever reason, that one seems to flow the best out of all of the solders that I've tested. At the bottom here, we've got the lead-free alloys, and these didn't flow anywhere near as much as the others did, and again that was repeated on here, and you can see these didn't flow very much on this board as well. So something about the lead-free alloys did mean that these didn't flow quite as well. So all of the others are pretty much similar. We've got the 2 Felder solders here, and this is the one with the addition of some silver into it, and it did spread very slightly more, and the same on the other board. Slightly more shiny joint, but not much between them. One thing to note about these two is that I actually had quite a lot of trouble getting rid of the flux residues, and it was the same on the other board again. This creates really quite a hard, crusty coating once the flux has flowed, and I had to really quite scrape it actually with this tip to get it to come off, even with using solvents and stuff. So those 2 solders definitely using some slightly more resistant rosin that didn't want to come off the board. But fairly interesting test. Certainly lead-free, not going to flow quite as well. The temperature was quite high, and on the hot air gun I had it up to maximum, so close to 500 degrees C, so it's not really a temperature issue. They just didn't want to flow quite as much. Right, so one other test I wanted to do is to use the same alloy and add additional flux to see if this changes how the solder spreads. So I've loaded up that pad with some Topnic AG5, which is a medium activity flux. So this one's the one with the additional flux and this one is the one without. And we're just using that multi-core 6040 Ursin 309 solder. So the same on each tab, and we're going to heat it up and see if there's any difference between how the two different solders flow. Right, so they've had an equal amount of heating, and you can clearly see the solder on the left here with the additional flux definitely flowed further on its own. And so what we can conclude from that is it's not just the solder alloy that makes a difference, it is the flux content and the type of flux that also affects how well the solder flows on the pad. Right, so what can we learn from these experiments? Well, first of all, I think there shouldn't be any brand loyalty. Pretty much all of the solders behaved absolutely perfectly, with the exception of the Jinhoo branded solder, which actually was not that cheap. It was just, you can buy it as a cheap roll because there's not very much on the roll. So this one misbehaved quite a lot. The mechanic was fine, and there are some comments about the sort of Chinese branded solders that they're not all that uniform across the entire length of the reel of solder. But I did unwind about 10 meters of this and test another portion, and it seemed to behave exactly the same. So at least this mechanic branded solder seems to be fairly stable, but all of the others were pretty much fine. So for general purpose soldering, where you're soldering relatively new parts, you're not really going to see any difference between any of the brands of solder. And also, interestingly, the lead-free solders are also absolutely fine. Certainly on the solder spread test, they behave a little bit different, but for actual soldering, again, they're absolutely fine and you're not really going to have any trouble. One thing that I've not tested, and where you may find some differences, is on much older components where some oxides have formed, the different types of fluxes may have a different effect. Obviously on newish parts where you've already cleaned up the board and everything like that, you're not really going to see any difference between the types of fluxes, but certainly the more acidic or the stronger fluxes are going to behave better on components or PCBs that are more heavily oxidized. So that might be where you're reworking old PCBs or something like that. But generally speaking, I mean, these are all designed to conform to various standards. So a lot of them have the British standards, and there are some others that they comply to. So they are going to be of a minimum quality, and really you can pretty much pick whatever solder you want to use based on its thickness. Really is probably the most important parameter. If you're using the solder for fine SMD work, you might want to use something like a 0.3 or 0.4 millimeter solder. Otherwise, a more general purpose sort of 0.7 millimeter solder is going to do the job. I think the Duratool solder was probably the best value out of the lot. It seemed to behave really well, and I think it was the cheapest per unit weight. But considering that if you buy a roll of 250 grams of solder, that's probably going to last you a fair amount of time. You know, the cost differential really is not that great. So hopefully you found that video useful if you are looking to determine what type of solder to buy. I'll put the link down below for this particular mechanic solder, which you can buy from Banggood, but all of the others are available from general purpose distributors. The lead-based solders are becoming a little bit more difficult to obtain in the UK and in Europe, but they're still out there. They're designed for professional use, so places like Rapid Electronics want you to have a credit account there in order to order the lead-based solders, but Farnell, CPC, RS and obviously eBay, you can buy them without any trouble. And TME in Europe also sell quite a few brands of lead-based solders, but given the tests that show that the lead-free solders aren't that bad, you're probably not going to have any trouble if you order these. So if you found the video useful, leave a comment down below or give it a thumbs up. And until next time, thanks for watching.